So it's going to look like that. Okay, so you get to see my like pin selection up at the top. So just ignore that. Okay, so we're going to talk about our algebraic expressions today and evaluating them. So we have a couple blanks to fill out here at the beginning. So the first one is the word variables. So at the top, we want to fill out the word variables. And then the second blank we want to fill out is the word constants. Okay, so an algebraic expression includes both variables and constants. And so if you're wondering, what do those mean? What are those words talking about? Let's look at this right here. So this first page, we're just going to be more listening to. We're not going to be doing as much writing. So we want to be watching up here on the TV. So a variable, that is the X or your Y or a Z or an A or a B, any letter. That is a variable. Okay, so these two would be my variables of the problem, the X. A constant is anything that doesn't have a variable with it. And so that would be like the 5 in this situation or the 7 in this equation. Okay, the 5 and the 7, those are constants. You're going to hear me say those are your regular numbers. What I mean by that is they don't have an X or an A or a Y or a Z attached to them. They are just constant. They are by themselves, okay? And then together we have an expression. So an expression, that is the combination of a variable term and a constant term being separated by a plus or a minus. So a plus or a minus would go in between them, depending on what the sign is. And then we can put two expressions together with an equal sign in between them, and we create an equation. So today we're only going to be talking about expressions, not equations. We're only going to be talking about one half of an equation or just one side, all right? And then finally this last word, coefficient, that one's this one right here. Coefficient is the number in front of my X, so or my Y or my Z, again, the number in front of your variable. So let's answer a very important question that's going to be useful throughout this unit. What is the difference between an expression and an equation? And I will tell us here. So we want to write this down together. An equation has an equal sign. Okay, an equation has an equal sign. And so today we are not doing anything with equations. We are only doing something with expressions. So today we won't see an equal sign in my problem. That means I'm not solving anything. I am just simplifying. And in this case, I'm evaluating and then simplifying, okay? So let's now talk about what does it mean to actually evaluate that expression. So again, today we're only going to look at just like this type of problem. No equation, just like a variable or two variables and some numbers. No equal sign. So how we evaluate is we want to use the substitution property. So on the next little category in our notes, we're going to use the substitution property. That's going to help us evaluate these expressions given the value of the variable. So if you're wondering, what does this mean, evaluate? Well, let's kind of give you an example here. Let's say if x is equal to 10. All right, so that's going to be my next blank. If x is equal to 10, right, remember a variable x or y or z is just a placeholder for a number. So we're saying I know x has the value of 10. Then x can be replaced for 10 in any expression or equation and vice versa. All right, so that means I can replace 10 every time I see x because they are equal to each other. We're saying x is 10. They are the same thing. And so our problems are going to look like this. We're going to be told to evaluate. We're going to be given an expression. And then we're going to be given a whole list of what my values are for each letter. And so the first thing we want to make sure we understand is that we are replacing the variables with parentheses. Okay, we're replacing the variables with parentheses around them. And here's how it looks. We do that by substituting. I'm going to substitute the value of my variable in for each set. So let's just take a look at 3x. Notice how 3x became 3 times 2, right? 2 in the parentheses. Why did I use 2? Because it tells me that x is equal to 2. So all we're doing is every time I see x or y or z, I'm replacing that variable with the number in parentheses. That is key because parentheses means multiplication, right? And what's really important to know about this is that 3x squished together those two things are being multiplied. Okay, so when you see a letter and a number squished together, that means multiplication. You don't have to put parentheses there. You don't have to put a dot. You don't have to put an X. Just squishing them together is enough in math to show those two things are being multiplied. So therefore, when I replace it with a number, I need to make sure that I actually use parentheses, because otherwise it would look like this. Otherwise, if I didn't, it would just look like 32. And then we would think that number is 32. That's not what that's saying. 3 times 2 is 6. So this is wrong, right? It's not 32. We have to show that multiplication with parentheses, okay? So let's go ahead and turn to the next side. That was just the kind of example already worked out for us that you can go back to if you need it. But let's try practicing this on our own now. All right, so we have 3a plus 5b. 3a plus 5b. So what I'm going to do is I'm going to understand that a is really 4 and b is really -3. And I'm going to use blue for 4 and orange for -3. So I'm going to just start by rewriting my problem. I see 3a. Because I see the letter A, I am replacing that with 4 in parentheses. Then I'm going to write plus 5. I see the letter B. So I'm going to replace B with -3 in parentheses. Again, that is multiplication. And so that's all I'm doing. Notice how I did not change the 3 or the plus or the 5. I just changed my letters. And so now I get to use order of operations. So my order, before I add anything together, we have to multiply. So I need to multiply 3 and 4 together, and I need to multiply 5 and -3 together, and then I can add those two things. So 3 times 4 is 12. We rewrite the plus sign. Yeah, 5 times -3 is -15. So good. When I add a negative, what does that really become? A minus. Good. So this is really just 12 minus 15, which is -3. Okay? Right? Positive 12 minus 15, -3. Okay, so let's go ahead and move on to number 2. So that's it, right? We're plugging in, and then it looks exactly like what we did yesterday. So let's try number 2. So number 2, we have x squared minus y squared. So x squared, that is a 6. So I'll use blue again for x, and I will use orange for y. So we have 6 squared. Notice I'm putting that 6 in the parentheses, minus. We're rewriting that minus sign. Then y is -5, close parentheses, squared outside of that. So what I've written in black is the same as my problem. I've replaced the blue 6 and the orange -5. And so now, again, I cannot subtract anything. I can't even turn that double negative into a positive yet, because that's breaking the order, right? That would be making a plus. That would be subtracting that. Subtracting does not come before exponents. So I have to do my exponents first. Good. So 6 squared is 36. I have to rewrite that minus sign because I'm not subtracting it. -5 squared is 25. And so now I can subtract. 36 minus 25 is 11. So make sure we do not break the order. Even though we may be tempted to make that into a positive, we can't. That's going out of order. Okay, let's jump to number 3. Number 3. This one I have a lot more going on, but let's take it step by step. Yes. Okay, so we have the minus. So I'm going to rewrite that. I see A. A I'm replacing with -3 in parentheses. I see B. B I'm replacing with -1 in parentheses. There's a squared after that. This time, I really can already turn that plus minus into a minus sign. Because look, there's nothing being squared here. I really am adding this next term right here, okay? So I can really make that a minus 2. I see C. C is -2. And then that C is being cubed, okay? So again, all I did there was just plug in A, B, and C. And then I changed that plus minus into a minus sign just to make it look a little bit nicer. We're really subtracting that group at the end. All right, now let's take it step by step. I first look inside the parentheses, inside all these groups. There's only one number there. There's nothing to work with. So I move to my next step of exponents. I see 2 exponents. I see this one and I see this one. So we're going to keep everything else the same. we're just going to change those exponents. So I'm going to rewrite the minus 3 in parentheses. Negative 1 squared becomes what? 1, right? Then I'm going to rewrite minus 2. Then negative 2 cubed. So we can write that off to the side. That's negative 2 times negative 2 times negative 2. So I have 3 negatives. So what type of answer will I have? A negative. Right, I have 3 negatives being multiplied. What's 2 times 2 times 2? 8. Good. So that becomes a negative 8. So again, all I did was change my exponents. The negative 1 squared, the negative 2 cubed. Then I moved to multiplying. I cannot subtract anything until I multiply. So I'm going to multiply this whole group together, and I can multiply this group together. And I'm going to keep that subtraction in between them. Right, I'm not subtracting yet. I'm going to do that first group multiply, second group multiply. So what's a negative, and what's this number right here between this negative? A negative 1. Negative 1 times negative 3 times 1. What does that give me?
3.
Just a positive 3, right? A negative times a negative is a positive. 1 times 3 times 1 is still just 3. It didn't change the value. Then 2 times negative 8 is negative 16. Notice how I carried that negative sign down in between them. I also have the negative 16. Here's that final step, so I am good to turn that into a big plus sign. 3 plus 16 is 19. Good. So that one was probably one of the harder ones that we will see. All right. So that one was pretty difficult. We had a lot going on there. All right, let's go to number 4. This one looks pretty challenging, but again, it's not. It's not that bad. So let's go ahead and try number 4. So number 4, I have m squared. M is 6, so we're going 6 squared plus m is 6 again, times n. N is 2/3. And then I'm closing parentheses, and then I write a squared. So this looks kind of weird. I have a lot of parentheses. These blue parentheses are the ones from my problem. And then I have an extra set of parentheses around the 6 and the 2/3 to show that those two things are being multiplied together. So this time, when I start with PEMDAS, right, we go parentheses, exponents, multiply, divide, add, subtract. Do I actually see something inside parentheses this time? Yes, right? I see that I need to simplify this before I square anything, okay? I have to go inside. So what is 6 times 2/3? We can use our calculator if we need to. 6 times 2/3. I'm going to rewrite everything else. 6 times 2/3 gives me what? 4. Good. So you could type that in. I want you. That's why we practice so many days using our calculators with fractions. So when we get to stuff like this, we don't need to waste our time trying to figure out how to multiply fractions. Type it in. Write your answer down. It's 4. Again, all I did there was do what's inside the parentheses. Now I do exponents. So 6 squared is 36 plus 4 squared is 16. Again, I do that next step of exponents. There's no multiplying and dividing. So I move to my final step of add, subtract. 36 plus 16 is 52. Okay, so again, that one looked a lot more difficult, but that was pretty easy. There's just a few steps there. All right, let's go ahead and look at number 5. So number 5, this is another example of something that looks a little bit more challenging, but it's just like the warm-up. We simplify the top, simplify the bottom, and then I move on. So let's go ahead and plug everything in. So for number 5, we have x squared. That's negative 1 squared minus y squared. Y is 5, so that's minus 5 squared all over x, which is negative 1, plus y, which is 5, plus z, which is negative 2. And so let's deal with just the top row, okay, the top part. So on the top, I see subtraction. Don't want to do that yet. I need to do those exponents first. So let's do 1 squared. Negative 1 squared is just 1. I rewrite that minus sign. I'm not subtracting yet. I now can do the second exponent, 5 squared. 5 squared is 25. There's my top part. That looks very easy. On the bottom, what operation do we see happening on the bottom? Just addition, right? Notice how if I took those addition signs out, then that would be multiplication, but everything's being added. So you're more than welcome to type this into your calculator. And we can also simplify this. That's really -1 plus 5 minus 2. You're free to type that in. -1 plus 5 is 4. 4 minus 2 is 2. That's what the bottom simplifies to. So really, when you're kind of adding numbers like that, you don't really have to put the parentheses around them. It may be helpful, but you don't have to. All right, then we still keep going. The top part needs to be simplified one more time. 1 minus 25 is -24, all over 2. Then -24 divided by 2 is -12. And there would be my answer. So again, I cannot type things into that calculator till I get to this last step here where I've started. Your calculator will not know what to do if you try to type all of that in. You got to have one number on top, one number on the bottom to divide. Okay, let's move on to the last one. So the last one, we see something that we maybe haven't seen in a while. These two bars. Does anyone remember what these two bars are called? It starts with an A. Absolute value. Good. So I would make a note. So in your notes, like how I'm doing, I would draw a little arrow pointing to those bars. Those are not ones. I would make a little note that says absolute value. But here's the question. Do we remember what absolute value does to my number?
Absolute value.
Yeah, we make the absolute value of it, but what does that mean?
Like if it's negative, it makes it a positive.
Good. We make any negative number, once you get down to one number, if it's negative, you drop it, it becomes positive. So we're going to keep that in mind, okay? So let's go ahead. Last one here. I know there's a lot of talking today, but we're almost done. So we have c squared. So c is 3. So I'm writing 3 squared plus 3. I see the bars. Inside the bars, I have the letter D, which is -4. Close my bar. Minus 4 times B. B is -3 squared. So that's all I did, was just replace C, D, and B with my numbers. And now I want to check, is there anything inside the parentheses? No, there's not. Notice how this is all just one number. I'm good to move on to exponents. So I have two exponents here. I have the 3 squared. I have the -3 squared. Nothing else is going to change, all right? So 3 squared is 9 plus 3. Because I don't have anything really going on with this absolute value, I can go ahead and just kind of drop that. That -4 inside the bars is really going to turn into what type of 4? Just a regular 4, right? So we can get rid of the bars now. So when I get rid of the bars, that means I drop the negative. But notice how I'm still keeping those parentheses there. That's still multiplication. But all I did was just get rid of the negative, because that's what the bars tell me to do. Then I can write -4, but now I know that -3 squared is 9. So I only changed those few things, right? I changed those squares, my exponents, and then I just dropped the negative with my absolute value. Now we need to multiply. What two things are getting multiplied? The 3 and the 4, good, and the 4 and the 9. So I'm going to rewrite the 9 plus. I'm not adding anything yet. 3 times 4 is 12. I rewrite the minus because I'm not subtracting anything yet. 4 times 9 gives me 36. And now I have all adding and subtracting, right? So we can type that all in at once. 9 plus 12 minus 36 gives us -15. And there would be my